Hey guys, what's up? So here you can see us setting up the first tank, and we're putting these 12 GPU nodes into it. We're experimenting with how we suspend them. I don't know. I think we could actually get more into the tank if we don't do this little suspension thing, and it doesn't seem to bother anything if they're just sitting on the bottom. So we're going to play around with different setups, but obviously we could get more GPUs into the tank, and and that is the idea. But today I wanted to talk about the hardware at the hardware level and the software at the software level. We've had a lot of questions on, pros and cons of immersion, and the temperatures and how immersion, affects the temperatures. I thought we'd cover that in detail today. And yeah, so let's cut right to it. So in this clip, let me turn the volume down here. In this clip, there's a couple parts that you can see that are a little different here. I've had a couple of questions about what this is. Well, this, you can see the green wire coming right here. This is ran to an earth ground. And this copper is just to pick up any kind of static that is in the fluid, because this fluid, especially if you're rubbing it against, flowing it through plastic, PVC, anything like that, it's going to pick up static electricity. The fluid will. And if you don't have any way for that static to get out of the tank, it'll build up, and the first thing you'll know is the tank kind of shocks you every now and then. It could do some catastrophic damage to the graphics cards if left unchecked. So what we do, and this is way overkill for this tank, and we're gonna change that out. It only really needs one of these set up by where the flow comes in, but it's essentially two copper strips, a little less than a quarter-inch thick, and then it's connected to this green ground wire down here. And that runs out the building and directly to an earthing ground. And that's a 4-foot copper stake that has been driven into the ground. So it's a really good ground for this particular setup. And maybe later I'll try to get some readings. It'd be interesting to look at what the static charge is with and without a ground. That would be an interesting one to even see if we even need this. Maybe it's working its way out of the tank through the feet, but I sure would hate to depend on that. So that's the first thing is talking to engineering fluids. They highly recommend doing some kind of grounding to plastic tanks for static electricity. And metal tanks, you can just ground the tank itself. And our new tanks that we're working on and designing, they're going to be metal, and we'll be grounding those directly. So that'll make the whole thing a little bit easier and not as messy. Okay, so the next thing is we take a little piece of angle aluminum. It's about 1.5 inches. And then we just drill these holes in them. And these A4000s have 2 holes for their brackets that they would normally use in like a rack machine. And they're just them 3 screws. So we just mounted it to a piece of angle iron for its stiffness, and just tied them to it. And it, believe it or not, it's actually quite sturdy. It makes the cards all kind of one unit. And at first we thought we might have to do some kind of a piece of aluminum around the front of them, but we don't. You tie it to this, and they can just sit in there, and they are just fine. We are playing with these all threads to tie them to the top to submerge them. We don't think we have to do that really. So that's something else we're going to experiment with. And if we don't do that, we could get more into the tank, but we'd have to figure out how to get more of the motherboards situated in here, and if I cut 2, we can see that. So the motherboards are on these aluminum racks there, and you can see here, it's the B250, but they're onboard ports, so we don't have to have those silly 4-port adapters or 6-port adapters or whatnot. They're on there. And it's set up. This is the easiest way we have found through all the iterations of running these GPUs and in any kind of number. This is what we have found works the best. You just use these motherboards, slap a Celeron CPU in there, about 4 gigs of RAM. That's all you need. I'm running. We do minor stat, so we're running MSOS, and it works great. You can run 12 GPUs on each one, and I couldn't be happier with the setup. You have your 12 PCIe lanes. This is the same kind of ports you'd get off those splitter cards, and you can hook directly into these, and all your PCI lanes are set up. The only settings I really had to change in BIOS, these things come pretty set up for you, but the only settings I really had to change was the gen speed. So instead of Gen 1, they come kind of set up for Gen 1, and I changed that to Gen 2, and you definitely get a little bit less consumption and quicker load times. I have not tried Generation 3. I just haven't had time to try it. It could work, I don't know, but I imagine that the lanes might not be there, so something to experiment with later. But you can see these wires just go straight into the GPUs themselves. Now, there is one warning. We used, you can't really see them here, but we used it's a narrow riser to let us get the cards as close as possible. Something else that we could have done is mounted each GPU the other way, and so one this way and then reverse this one. So you have a riser on one side and a riser on the other side. You could do that and get them even tighter, and obviously we didn't think about that until after the fact. But we used a narrow riser. We found a good deal on some, and they've worked great so far. And then you have the power supplies. These are from Parallel Miner. They're the 1400 watts, and we have the amp cards, on them, just so we can see the amp load on each bank, and in each one of these, we split the cards. There's 12 cards, so half of the cables go in one, half of the cables go in the other, just to split the load as evenly as possible. And you can see we're really close. I mean, it's 64 on one, 63 on the other. That's with an error on this measurement device. So it's pretty close, and it's just a simple little design. And so I was talking about getting more GPUs into the tank, and as you can see, we're kind of limited on. Let's see if we show a top part. Yeah, we're kind of limited on how many motherboards we can get up here on the top. So what we're probably going to end up doing is coming down to the bottom and mounting motherboards to the bottom of this. And technically, we could just put them in the tank as well. And there's no harm in putting the power supplies in the tank, the motherboards in everything could go in the tank. Obviously, we want to save as much of the room in the tank for the GPUs, because those are making the bulk of the heat. I will get the flare out, because that's kind of an interesting. You can actually see the temperature differences in the fluid with the flare gun. I thought that was really, really interesting. You can see like the hot swirling in cooler fluid. I'll definitely have to make a video of that, because that's probably one of the most interesting things about it. But to continue on with these tank setups, I think I'm going to change the input and output just a little bit on the next tank. But this is our input flange here, and I've since put a small piece of pipe here inside this tank. I have found you don't have to glue anything together; just compression fit it together, and it'll be fine. Our pressure coming out of this is not that high. But I've got a small piece of pipe stuck in there, and then I found some like jacuzzi nozzles or swimming pool nozzles that were the right 1.5 inch size, and that's pressed onto that pipe. And now I can like direct the flow where I want it to go, and I direct that flow to go right behind the GPUs. And what that's done is it's made the flow go down here, and it kind of makes the whole tank kind of circle. I was really worried about flow on this thing because you have one big open tank. You've got one drain here, and how do you efficiently get rid of the heat? Because our production tanks are going to have a center channel overflow where the fluid comes in from the bottom and overflows into the middle. But on this proof of concept tanks that we were setting up, we wanted to have one. We needed the data for what do you got to do for these A4000 style cards. How do they all react to immersion cooling, that kind of thing. So we're really just doing this to learn a bunch, from it, because going bigger and scaling up is what we want to do. But so this comes. It's really hard to see like how the things are going. I'm gonna do some more videos on how these tanks are set up, so you can see this kind of thing from without the fluid, because the fluid distorts. It like it's making this thing look small, but this thing comes up to about 1 inch from the top of the fluid, and the idea being the hotter fluid will be at the top, and this is sucking the hottest fluid that it can. I really, really, really wish I'd have put that in the middle, but after changing this to push the fluid around, back down this back wall, the tank temperature is very stable right now. We don't have a whole lot of power running in it right now, but right now it's stable, and this little setup is working just fine. There's a closer little shot of how the GPUs are attached here, and we didn't have to drill or tap. These A4000s come with these holes already in them. Just get you some M3 screws, and right here in the blower is actually a void that these screws are going into, so it's perfect. It doesn't interfere with the fan or the flow of fluid that's going through the GPUs. And man, it was just the easiest thing I could figure to do to get 12 GPUs to stay together, using just one piece of relatively inexpensive aluminum angle that you can get at any Home Depot or Amazon or anything like that, and and we just cut them to size, and then drill the holes. We have a little jig that we use a drill press and just pop 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 pop. Yeah, so that's the general setup here, and then of course we use thumb drives for for the OS and that kind of thing, and then I can't think of anything else. We had to use a power. It's not here right now in this video, but we had to use an extension here to help us arrange the power supplies better. Now it's all kind of tidied up, and I need to get a current video of this tank. Okay, so it's the next day. I went ahead and got some video just to kind of show what we had to do here. There is a little motherboard power extender, the 24-pin extension on these motherboards, and you can see like we tidied up the powers a little bit and whatnot, just make it a little easier to work on if we need to. But here you can see it just gives us that little extra room to move the power supplies, wherever we want them, kind of thing. And then the framing on top, there's an angle that runs across this side of the tank like that, and then there's one that runs on this side, and we've screwed it into the tank at the corners, and it extends past, and then we just have other angles that we just pop some. It's super simple build. This center rack is tied together with an all thread, and we can change where we want it in the tank by just twisting the bar here. So if we want to slide it over one way or the other, you just turn the bar and you can move this rack. I still don't know if I'm going to do motherboards on the bottom of these plates, which would be fairly simple to do, or if I'm going to try to like fit more plates in it. We're still debating on what to do there. So that's kind of the view of the tank now as it sits, with all 48 GPUs running. You can see there's a little kickback on the fans. That's just because those fans are made for air. They're not made for fluid. I've even been in contact with NVIDIA directly and talked to the manufacturer of the cards. They did absolutely no testing for immersion. And the weirdness that I have found with these cards, which is not a big deal, but the weirdness that I have found, and this is kind of sad, but they're not even going to do custom BIOSes for enterprise level people, which I found is real interesting. It's a what you get is what you get kind of situation on these A4000s, because I guess they're not going to deal with it. They never tested it for immersion. They were made to be all cram packed together in a rack case with a lot of airflow. So it's an interesting situation, but I can't believe they didn't do any kind of testing for immersion on these cards. It's like they made them for immersion, but then didn't test it. So, hey, what are we gonna do? It is what it is. I do have a cool one here. It's running at night, and here the cards are running at night, aka the lights turned off. It's a crappy video, a lot of noise in it, but I thought you'd get a kick out of just what it looks like with all the risers. The brightest risers I've ever seen. But they work. These risers work really well. And yeah. Okay, so we'll let's kick over to the actual mining setup themselves. Okay, so let's talk about the software themselves. And here you can see the 1 through 4 here. These are the emerged rigs, and then these are not. These are in 2 different locations. These 2 are in. Oh man, I can't even tell you which one is which. I think 7 and 8 are at the second location, and then these are at the same location. And this right here is the number one reason why you want to do immersion cooling. So you can see this tank is sitting in the same room as these, right? And it's probably about 90 degrees Fahrenheit in the build, 95 degrees Fahrenheit in the mining room. And this is why you want to do mining. These have a lot more cooling at the second location. So right away you can see these are running 100 Celsius plus on the memory. Oh, and by the way, MinerStat now, or T-Rex now, reports memory temperatures in Linux. Oh man, we have been fighting for that one. Okay, so and when these, obviously when GPUs get hot, they use more power. So just making them cool, you lose about 50 watts for the whole rig. It's about 50 watts less. And let's just take a look at it. So we have this is the hot one running at about 1611, and this one's running at about 1568. I've seen average it's about 50 watts that you save from a rig being hot and a rig being cold or cool. But every one of these are in the 100-degree range on the memory, and about 75-ish, 74-ish on the GPU, and we're running those at about 1200. I've tried, settings of 1165, whatever. 1200 seems to do just fine. Air cooled, 8100 is pretty good, depending on what your temperature is. But you can see, like, on our temperature, it's definitely been getting warmer today, and it's going to be a lot warmer soon. That room will probably be about 100 degrees Fahrenheit. And that's okay, because immersion doesn't care. We get about 62.4, about 62 and a half. Now the immerged tank is a completely different story. They're 49 to 53C looking like, and the memory temps are 66. We've done no memory pad changes on these. The only thing that we have done to these cards is change out the thermal paste with an iridium pads foil, and because you can't use thermal paste in the immersion tank because it'll just wash out. So this is even using the iridium pads that are about 1 millimeter, 0.1 millimeter thick. And these are the kind of temps you get out of them. We did nothing. We didn't even touch the memory pads. And the A4000s are slightly better than what the 3000 series memory pads have been. I've noticed that you get a little better across the board. But there's a reason for that, and that's because the way that the A4000 is set up, the memory doesn't go through the heatsink that the GPU is using. The memory is cooled by the whole aluminum part of the card. The whole case of the card is what cools the memory. So the byproduct of that is, make that aluminum cool, you're going to have much better memory temperatures. We're going from 110, 104, 108, 102 to 66, 64, 66, 64. Huge difference. Huge. And the only thing that's happened there is the card was immerged. And you got to remember that temperature, the fluid temperature it can't be better than ambient, right? So these cards are cooled by air, the same ambient temperature air. These immersion cards are being cooled by a dry cooler using the same ambient temperature air. So, yeah, it's just the efficiency of immersion fluid wrapping itself all around that. The immersion fluid is much more efficient at wicking away the heat from the card than air can. So that's how they can both be cooled. The dry cooler that is cooling the fluid can use the same 95 degree air to cool the fluid down to 30, 35 C, something like that, whatever about 95 degree Fahrenheit is. And you get that much improvement. Now I haven't done it right now, and I guess we could try it. I don't want to mess with it right now, but we can easily get 65 mega hash out of the immersion cooled cards. You can also get it out of the air cooled cards if you have a lot of airflow. But we didn't want to go with the whole let's make the biggest wind tunnel in South Texas. Just wouldn't be. I know there's a couple of mines out there that do the whole let's flow as much air through as possible. We don't want to go that route. One, the maintenance for cleaning cards and dust all over the cards and all of that, it's too much. It's just way too much work. And we figured why do that? When these cards come out of the immersion fluid, they come out and you pull the card out. Like, let's say you want to remove it permanently from the fluid. If I was going to sell a card, you pull it out of the fluid. We have a dielectric. Immersion Fluids also sells the cleaner for them, which is also a dielectric fluid. You could technically run the card in the cleaning fluid. So you basically just dip the card in the cleaning fluid, and then dry it off. And when your card is dried off, it looks brand new. I'll at some point I'll do videos of this just to show how your cards come out of here. The other thing is that all the fanage, all your cooling is happening at the dry cooler. It's not happening in the mine because in the mine is, just tanks now. That's our plan is to, everything's going to be immersion cooled. And our mine will be pretty much quiet. There's not going to be any fans other than like the power supplies, and they're fairly quiet. And we might even end up immersing those. So the more I think about it, the more I want to do it, because why not, right? Why not put all the heat into the fluid? So it might be something we try on the second tank that we're setting up, and we'll go from there. Which way is the best way? Now, there is no off-the-shelf kind of like manual on how to do immersion cooling, so you kind of have to just DIY, figure it out, this kind of thing. And what we're hoping to get to is where we're going to be making 10-foot long tanks with 2 cooling chambers and then an overflow in the middle, and we're going to kind of like build our own little standard, and we can build the tanks for about half the price anybody will sell you a tank for. There are some. Immersion Fluid sells a tank. I've even found some local companies that will build the tanks for us if we wanted to. But what I found is it's literally about twice the cost, or even more than twice the cost of what we can build the tanks ourselves for. So we got a really good welder, fitter, fabricator, and it's just easy enough for us to build the tanks out of sheet metal and go from there. At least that's the plan right now. We could do aluminum, but I think we're going to start off with steel tanks, and then we're going to have our own little standardized thing for it, and our nodes will just kind of go one, right beside each other in the tank, and then the tanks can also hold ASIC miners, and each tank would be able to hold 30 ASIC miners. It's kind of what it's based around. We just happen to shape the GPUs to fit in it too. So we probably would never mix them like that, just because you can use cheaper fluid for the bit miners. So we're it's going to be an interesting next couple of months, because we definitely have some stuff in the works, in the mine. So I definitely wanted to just show how the temperatures are that much different from air cooled to immersion cooled, and why we do it. One, it saves us a little bit of power per rig, about 50 watts per rig. And 2, the cards stay clean. The maintenance is far less. It's easier on the card because the card is running at a lower temperature. The GPU and the memory are both at a much lower temperature. You can get more hash rate out of them if you want to. That 50 watts that you saved, if you want to use that 50 watts, you could put it into memory overclock and get a couple of more hash rate out of it. Even 1 mega hash per card on 11 card or 12 cards, you get 1 mega hash more. That's 12 mega hash total. If you can go from 62 to 65, it's a big deal. I mean, it adds quite a bit to the hash rate. And I'll definitely make another video of us cranking these up and seeing what we can get out of each rig. I've already done some experiments, so I kind of have a good idea. But I definitely want to make a video because that's a lot of fun. Yeah, so I think we'll wrap up there. Next time we'll come back with some overclocking and more immersion tank building. I definitely want to go over more of the build itself. We definitely have more There's more rigs. This is just where, I just wanted to show the immersion tanks versus the uh, non-emerged tanks, all using A4000s. These are all A4000s. Um, 4 of them merged, 4 of them not. And just wanted to show, like, even when you have a cool room, they still run pretty warm. 60s and 80s, um, 60s and 90s. These are on 2 different sides of the room, so this side is a little bit cooler, obviously. That would be like your best case scenario there, and that has a ton of airflow going across that rig, and it's mid 60s and 80s on the memory, and this is okay. Like, you could definitely run it at this, um, but we just definitely wanted to get into a situation where the other problem with this is you're not overclocking that much more than what the standard, get it to about 62, 8100 megahertz. Because you go much higher than that, they really start making a lot of heat, and the immersion cards can handle that much easier. And we'll definitely do some experiments in the next video on overclocking these puppies. Hey, hit that like, hit that subscribe, hit the bell if you want to get notified on future videos. And I thank you very much for watching, and we'll see you.